Afternoon, everyone. So I believe already joined in. Even we have 33 uh, people in this class. Again, I think the I'm not sure if the faculty or the UC did release. Let me check. I think no, it's okay. Because of the COVID surge. I just want to highlight again and again. If let's say later on, any of you is under close contact, then you all have to be quarantined. But if you all is just, I mean, any of you lah, just casual contact. I mean, show in my sejahtera casual contact still is okay to come to class physically if you are initially opt for physical class. Okay, so this is based on the SOP from the MOH lah. Okay, so if you have any concern, do raise to me. And if also you are casual contact and you don't feel like you want to come to class, just email me. I can excuse you from the class. Okay, you can opt for the online class. Um, yeah, that's all. So the same thing. If let's say touch wood, I am the one who COVID positive or close contact or maybe casual contact. So perhaps I will change the class and tutorial to online class. Okay. I have to notify you this one from time to time lah. Okay, because I cannot foresee next week or next week or something in future. Okay, so if let's say this happens, so I will let you all know in the Google Classroom, and I will also ask Chie to help me to distribute the message. Okay, so don't worry about this, but do I mean at least be prepared that oh suddenly the class is become online. But of course I will notify you as soon as possible lah. Okay, let's say maybe we have class later on like 1 p.m. and then this morning I only be notified via my suggestor that I'm close contact, so I will notify very soon lah. Okay, just to seek your patience on this one. Okay, we try to um overcome the COVID surge. So I think that's all for the highlights. We continue our class. Let me start recording first. Anyhow, we don't have any. I mean, the examination mode still status quo, which means we will be in physical examinations at the end of this semester. Okay. If there is any update, we will notify you very soon. Let me share my screen. Any questions so far before we start? No. If you have any question, just put it in the chat box. Okay, so we continue our class. So in the previous lecture, we already done for some of the operations because this lecture, I mean this chapter is meant for manipulation, right? So we have a few type point, local, and transform. So just to recap, point operation the is to apply the manipulations in only a point. Okay, we only concern a pixel and the information or any information surrounding the center pixel is not being considered. Okay, a typical example would be the thresholding. So for thresholding, let's say we have gxy. Let's say we have gxy. We have gxy is equal to our input, perhaps fxy greater or equals to 60 is equal to 1, else is else sorry else should be else should be okay, should be 0. Okay, something like this. So this is a typical example for point operations, which means you only consider only a certain point, which is x and y, z, the very specific pixel that you want to consider. But for local operations, we will consider the surrounding pixel. It depends on how many connectivity. But I believe in your syllabus, we did not really mention, I mean, the connectivity is not included in your syllabus. So this is just for your information. Let's say you have a 3x3 pixel. So this is the origin. So for connectivity, this would be the pixel that would be considered, which is this one, this one, this one, this one, which is just left and right, top and bottom of the origin. If it is an 8 connectivity, so which means you will consider all the 4 directions. Okay, these all would be considered. Okay, so uh this is 4, this is 8 connectivity. Okay, you can actually fine tune, I mean, use these 4 connectivity or 8 connectivity in MATLAB, especially when you are using morphological operations, I am erode, I am dilate, I am open, I am close. All these morphological operations would consider 4 and 8. If not mistaken, by default, it is 4 connectivity. Let me think. I'm not sure it is 4 or 8 already. You need to check back with the um MATLAB, which is you can type IM erode space MATLAB. So by default, they will have their own parameter over there. Okay, so this is the type of connectivity. So okay, let us continue with the local operations. So local operation is the operation that will consider the neighboring pixel. So let's say you have a pixel with a window size 3x3. Okay, so this is your origin. So the rest of it, this one, all are the neighboring pixel. We know it as neighboring pixel. Okay, so let's say we consider all the neighboring pixel. So for example, you want to calculate average. Let's say this is to the pixel intensity is um, to okay. So which means it's 18, right? In order to calculate the average pixel. I mean, if this is a mean filter, mean filter. Okay, let me just give you a brief introduction on this. All the filter is actually sort of mask. So this one 3x3, 3x3 or 5x5 or 9x9, all these are sort of masks. So another, I mean, another way we call the mask is known as window mask or filter. Okay, actually it is more or less, I would say it is equivalent. Okay, the definition is more or less the same. So if you want to use a mean filter, which means you perform mean calculation, which means it's average. So you, since this is a one types of the local operations, you will need to calculate, I mean consider all the pixel within your mask area. So since this is a 3x3 mask, which means you have total of 9 pixels lah. So in order to consider all the value, which means 2 plus 2 plus 2 plus 2 plus 2 plus 2, total of 9, 2, which means all the pixel here lah, divided by 9. Okay, what is it? So which means it's 18, right? Divided by 9. So you will get 2. So the final pixel would be 2 lah. Okay, the output pixel that this to output this pixel is referring to 2 lah. Okay, the same thing if you want to put it as a medium filter, so it's the same. First of all, you need to sort all the pixel value, because the pixel value are 2 here, so you need to sort it in ascending order. So after sorting in ascending order, you pick the middle one, which is the medium filter, and replace with the current center here, this one. Okay, I show you another color, this one. Replace with this pixel value. So that it is. Okay. So I mean, when will we use the medium filter, the the mean filter? I mean, the most common application would be your camera lah, especially your IG, the Instagram, any other application that smoothen your face, beauty camera, all those smoothen the texture of the face, this and that. All that is actually using mean filter and also medium filter. Okay. That is why when you use, especially when you use mean filter, the image would be a little bit blurred. That is because you average out all the pixel intensity and replace with a new so-called a virtual value lah. Because this value could be unreal. This value could be unreal. For example, you have 1, 2, 7, 8, 9, 10, all these value add together, and then you get the mean value. You might get something different. For example, you might get 7.2, and then you round off to become 7. So for this value, I mean, this intensity is not belong to the um, picture itself or the image itself. So this is so-called we so-called a virtual pixel lah. Okay, this pixel is obtained via the calculation of averaging the entire neighborhood. Okay, so by replacing all the pixel using the mean value, somehow it will create something blurred out. Okay, so that is why when you use those beauty camera especially, you will feel like the contrast of the image would be decreased, but smoothen out a lot of um, salt and pepper noise, this and that. For example, some dark pigment on the skin could be reduced. The intensity of the dark pigment, pimples, acne, and etc. could be reduced or blurred out. Okay, but at the same time, you will find that the uh, edges in the images would be blurred out as well. Okay, so this is the power of the mean filter and medium filter, as well as the some of the trade-off lah. Okay, if you are meant to be used like for example, in beauty camera should be fine, because that is what we want, right? But if you want to use for something in precision industry, for example, non-destructive testing and evaluations in semiconductor industry, or maybe in medical image analysis, perhaps this is not an ideal case, because when you remove some of the high frequency information, which is the sharp edges, the contrast between the tumor and non-tumor edge, maybe you already shrink down the area of the tumor. For example, in like the MRI for the brain tumor, if you shrink down, if you apply the medium filter, yes, perhaps if the medical images is being corrupted by the salt and pepper noise, you can apply medium filter or mean filter to sort out the most of the salt and pepper noise. But at the same time, you are actually smoothen the entire image as well. So when you smoothen the entire image, the original sharp edges would be removed. At least reduced in intensity. So when the when the edges is being reduced in intensity, so it's quite difficult for you to identify the exact size of the tumor. And this is regarding to the diagnosis and also prognosis of the procedure, diagnosis and prognosis procedure later on. So it's very important for us to maintain and also to preserve the most of the informations inside the in any image analysis, especially for example the medical image analysis. Okay, so sometimes the advantage and also disadvantage, you need to prioritize according to the applications. Okay, you have to know what is your ultimate objective and what you want to achieve at the end of the day, and what trade-off you cannot tolerate. Okay, if you cannot identify all this, it's very difficult for you to select the best filter or the best image enhancement method. Okay, so you must be very clear what you are going to use this for, what questions you are going to resolve, and what is the problem statement at the hand. I mean, at this moment. Okay. So yeah, that is one of the typical example for filter, and I mean especially for local operations. So local operation or spatial filtering. Again, the word spatial filtering. Spatial is spatial is actually dealing with space. So I think I already mentioned too many times. Um, Image is a 2D signal whereby you have x and y axis or m and n axis. So the x and y axis is actually a 2D array whereby you have the image is actually like a Cartesian point lah. Okay, and the amplitude of any particular Cartesian point would be the how do I say would be the intensity. Okay, and the intensity could be in the range of 0 to 255 and also 0 to 1, depends on if it is being normalized. Okay, so spatial filtering, why we use the word spatial or elsewhere, I mean in the exam assignment or lab, if it is mentioning the spatial words, it is a keywords to notify that this is a um, operation which involves spaces, and image did have the spaces. Okay, images did have the spaces. So spatial filtering is a neighborhood operation. The pixel value is transformed depending on the pixel value and its neighbor. A pixel neighborhood is a set of pixels defined by their location related to the pixel. So the function determines a pixel's new value based on its current value and that of neighboring pixel. Okay, so as I mentioned just now, let's say this is the origin. So if you were define this is a 3 times 3 pixel lah. Okay. So all these are the neighboring pixel. Okay. And for local operation, you have to consider all of these to determine the final value here. Oh, I like that. Yeah, it's okay. Okay, so spatial filtering is used to blur or sharpen the image to introduce distortions, produce a variety of special effect. Okay, so this variety of special effect is depends on how you manipulate the filter. For example, you have a filter, you can manipulate it like, you know, this is the origin 1 1 1 1 and the 0 0. Different types of filter you can actually being used for different applications. For example, I think you all already try with Kenny, Prewit, and Sobel, some other edge detection filter. Actually, all these detection filter, it is using the spatial like this kind of filtering as well in order to get the ages. Okay, so the theory or the philosophy behind the filter is very simple. You just apply and calculate the center pixel according to the number or the patterns of your filter or the mask or the window. That's all. But sometimes you can actually alter or change the or design the filter to make it like with different applications lah. Okay, so it is like a platform, for example C++ platform or maybe Python. So you can use this Python platform to develop all sort of code, something like that. So this spatial filtering is just a platform. You can use this method or this technique to develop all different kind of window mask or maybe filtering effect to achieve whatever you want. So that is why you can use the filter, of course, different filter to blur or sharpen the image. So this is totally something too extreme lah. One is sharpen, one is blurred out. So it is two different extreme, but you can still using different filter methods to achieve this one. Or introduce distortion. For example, you can introduce distortion by using a very large size filter, maybe 9 times 9 filter, 9 times 9, and it is a mean filter. So when you are changing the center pixel, you are considering all the 81 pixels surrounding the center origin. So all these 81 not 81 80 lah, because 81 minus by 1, which is the origin. Okay, all these 80 neighborhood pixel would consider uh or I should say would be contributing to the final pixel of your origin pixel. Okay, so that is how you can introduce distortions and produce variety of special effect. I would say each detection is a special effect, because from the image you can apply Sobel filter or maybe some other filter in order to extract only the sharp edges. Okay, so that would be the some of the application for spatial filtering. So this is the mask and this is your original image. I mean, the whole slide would be your original image, and this is the mask. So let's say this is the current pixel, the dark one, and this is the original. So you apply this one, you apply this one into the on the image, the input image, the mask origin. So apply this onto this one. So all these pixel would be considered to change or not change the current pixel value. Okay, so the output would be dependent on what is the uh, spatial filtering you are using, what is the value here, and also what is the value surrounding the current pixel. Okay, so this is how we actually implement, and the new pixel value is your output lah. Okay, and put it and replace using this one. Actually, the theory behind the spatial filtering is exactly the same like the point operation. The only things difference is that for local operations, you will consider the information in your surrounding neighborhood. But for point operation, you did not consider. That's all. Okay. So a mask is a filter. Concept of masking is also known as spatial filtering. So this is just a concept lah. And sometimes you would found that some website they use the word window. It's the same. Okay, window mask filter is referring to the same thing. So concept of masking is also known as spatial filtering. So the process of filtering is known as convoluting a mask with an image. Therefore, filter masks are also known as convolution masks. Okay. The process of filtering and applying mask consists of moving the filter from point to point in an image. So let's say this is your original input image and this is your mask. Usually the mask would be smaller than your original image. Okay. Um, yeah, usually would be smaller lah. Okay, let's say this is a 3 times 3, this is 100 times 100. The origin is here. Okay, so this mask would be put on here. I mean, origin to origin. This the origin is star, the origin is star. So you put in here, and then after done, next pixel, next pixel, next pixel, continue until finish the entire image. Okay. So this is how the mask is being applied. So that is why sometimes when you have a very complicated mask, I mean you design the mask yourself and you will apply on the image, especially using MATLAB, sometimes it would be slower like, because you can assume you can actually imagine a filtering mask which is 3 times 3 and then your original input image which is very big, so you need to perform the execute the calculation one by one. If let's say you have 100 times 100, so it's around 10,000, right? So should be fine. But 100 times 100 is very small, the image. Usually you have maybe 300 times maybe 100 1020 200. So this one the image would be very big like. Okay, and to process this could be time consuming as well. Okay, and and the and the uh and the how should I put it, we don't really, we don't, I mean, this to process the image is not really, is not exactly like, you know, zigzag like this one. Sometimes it could be until here and start again as next line and continue until you finish the entire image. Why I would say in this way is that it is depends on the software. Okay. If you're using MATLAB, maybe you are using this method. But if you're using other platform, it could be this method. Okay. So it is the main purpose, the main point is that your mask will be applied on each and every pixel in your input image. That's all. Okay. How the image is being processed, the sequencer, is depend on the software itself. Okay. Sometimes the software prefer this way and sometimes prefer that way, but this is by default lah. Okay. Uh, of course you can control lah. You can control the sequence of processing the image. Of course you can. Just that you need to define the sequence by your own. Again, the MATLAB and also Python, C++, Boolean, all these are a software which is a platform for you to develop your algorithm. You are freely to develop. Not a must to use all those core function. But if you can use all those core function, you would be very skillful lah. But if you did not use all those core function and you write the function by your own, I think it would be better because you know the parameter, you know the original equation very, very well. Else, you wouldn't be able to succeed in writing the algorithm. For example, you want to write the algorithm for a simple thresholding, you have to know how actually being defined to consider all the um, conditions, then only you can write a successful thresholding. Even thresholding for beginner might be time taken. Okay, so so correlation consists of moving the center of the kernel. Yeah, kernel it has the same um, synonym to mask, filter, window. Uh, yeah, all these are same. Okay, center of kernel over an image and computing the sum of the product at each location. So the mechanics of spatial convolution are the same, except that the correlation kernel is rotated by 180. Correlation tells one how similar the kernel is to the image at any point. This is used for image alignment and simple image matching. Um, Correlation is something uh maybe it's a bit vague here, but just for your information, especially when you are, later on work in the AOI industry or semiconductor industry. Of course, not the manufacturer lah, but the inspection, especially for non-destructive testing and evaluations. Correlation is something very important and interesting because correlation is the very common mathematical algorithm that used to measure the similarity between two image. Okay, let's say you have an image A, apple, image B, apple as well. Okay, and image C, an orange. Okay, so this is A, B, and C. So by using the correlations, you can actually find the similarity. So the higher the similarity, the higher the value. And of course, a correlation is just general terms because inside correlation, under correlation, there are many more different methods to perform the correlation, to calculate the correlation. Okay, there are many more methods to calculate the correlation. So correlation is just general terms lah, to calculate similarity. So this is especially important in the semiconductor industry, not really semiconductor alone, but all those non-destructive testing and evaluation industry, especially involving AOI machine, automated optical inspection machine. So usually they will try to learn, learn a gold standard image, which means this image is perfect. The die is very perfect, no defects on the die surface. So that one is the gold standard or the best. They would call it as a template image lah. Okay, then you keep on for each and every conveyor belt. Die in the conveyor belt. This they will snap the image, and after snapping the image, they will compare this image to your template image. So if the similarity is higher, which means first of all, this is a correct image lah. Because sometimes in the productions, the incoming lot mixed up, could be mixed up. But of course, this would be very rare lah. Okay, if it is mixed up, so the it is a wrong production now. You have to stop the production and redo lah. Okay, but most of the time, why we want to calculate correlation is to find the age of the find the object in the input image. Let's say you have this is your image, and this is the pocket for the die, and this is your die. By using correlations, you can actually capture this die accurately. Okay, you can actually capture this die accurately. Assuming this is a conveyor belt, so when the conveyor belt is moving forward, the die in the pocket, die is like the sort of pocket, and then the machine will put in a die inside. Okay, this is a pocket. This is the pocket. Then it would be, I mean, the die would be put inside lah. So this is a pocket. So you will capture image here. Okay, capture image. So whenever the conveyor belt move, because this involve a movement, right? So the die inside your pocket would be, jumping here and there. Of course, yeah. It will. I mean, the depth of this pocket is deep enough to avoid this die being jumping out, lah. Okay. But that would be another mechanical department issue because they should design the belt accordingly. Okay. So your task for vision engineer is to capture the image and from the image detect the die. Okay, so if let's say you are using correlation, you can easily compare with the template image. Oh, this is the die. Okay, and then you capture the age. Why you need to capture the age of the input image is that you want to measure I mean, you want to detect any defects on your die. Let's say this is a gold standard die. You have 1, 2, 3 matrix code. Okay, you will check if there any crack, any contaminations, any tombstone, this and that. All these are an example for defects, surface defects inspection. Okay, so by using correlation, you were able to capture the edge and fit this edge. I mean, rotate this edge accordingly. So that is how you actually perform all those detections, surface detections. This is why we are using correlation method. Okay, and at least you have to know lah. Correlation is for similarity purposes, and if you are doing the face recognitions, actually you are trying to sort out the correlation as well. Eventually, in deep learning, in order to identify if this is a tiger, this is a lion, and etc. You are calculating correlation as well. Okay, the higher the similarity of correlation, I mean, the higher the return value of correlation, the higher the possibility this uh, object is associated with a particular cluster. Okay, so this is what correlation is going to tell us lah. And convolution is a process. This Convolution is a process in which the value of an image are multiplied by a kernel, which is the mask, and each output pixel is altered by contributing a number of adjoining input pixel. Let me clean this slide first. So this is the origin. Again, this origin is very dependent on your software. Not all software assign this as the origin. Some software assign the center of the picture or the image as the center point. Okay. So let's say this is the filtering canal, or the blue color one is the filtering canal. So this would be the locations, and this location is actually the one that I aforementioned, which is 0, 0, which is -1, +1, something like that. Okay, -1, +1. So from there you will get your value like this one. Yeah, exactly like this one. So xy, x minus 1, y minus 1, this is a typo here. X minus 1, this is y minus 1. Y plus 1, this is x plus 1. Okay. This slide is just for your information. So basically the correlation and convolution would be just 180-degree difference uh, in order to perform the calculation itself. So I will explain zero padding later on, especially I think in chapter 7 for morphological operation. Let me give you a brief idea what is zero padding. For example, you are applying the filter on the top left pixel and your mask is a 3 times 3. Okay, so this red pixel here is going to match with this red pixel. Okay, but by matching this one into this pixel in the original input image, this and oh, why like that? Ah yeah, one moment. So let's say this is your original input image. This is your the orange color is the pixel, I mean top left pixel. So you want to apply your filter. Okay. So this and this don't have any pixel inside, right? Because you only have pixel here. I should use another color, maybe green color. You only have pixel here. You don't have any pixel in the red color cross area. So uh, we cannot perform image processing without the pixel. Okay, so by default, eventually the MATLAB or any other software, they will perform padding. Okay, we call this as padding. Padding is a method to add in extra pixel into your input image. Zero padding, which means you add in zero pixel. I mean the intensity is zero, not zero pixel. Okay, they will add in intensity 0 into your pixel point. So with that, they will add in, let me pick blue color. They will add in one more extra pixel at the side of it. So all these pixel, the intensity is 0. So we call it as a zero padding. Okay, this is the philosophy of padding. Okay, why you need to put this padding to allow the mask apply to the corner pixel, which is the border pixel lah. Okay, the border pixel. So applying this one, you will consider this the value is 0, 0, 0, 0, 0, 0, and this is the default value, default value, default value, default value, default value. Okay, so you will have 4 default value, and the rest of it, these are zero padding. Okay, zero padding is here. Okay, so this is meant by zero padding. So in order to that is why here shows zero padding here. So you apply the mask, I mean, at the right hand side coming in. So you will get the mask because you have only one here, the rest is 0. You only have one here, the rest is 0. So by passing through your filter, this is your filter. So this is your input image. This is your canal. So by passing this one at these directions, whenever it's passed through the one multiply by 8, you get 8, right? One multiply by 2, you get 2, right? So that is why you will have 8, 2, 4, 2, 1, 0, 0, and so on. Okay, this is because keep on passing through this one, matching out, matching out, matching out, matching out, and follow the sequence, you will get this one. Okay, and for the convolutions, just 180-degree rotated, which means your mass initially is 1248, right? 12428. Now become 42421. Okay, just rotate by 180 degree. So the same philosophy. You have your zero padding. You have your canal here. You have your input image here. Okay, so this is the direction, moving directions. So when it moves to the first one, matching, 1 multiplied by 1 is 1, 1 multiplied by 2 is 2, 4, 2, 8. So that is why at the end you will get 1, 2, 4, 2, 8 lah. Okay, so this is the only difference between the correlation and convolutions. Okay, but of course, if given in the exam, it will give you the sequence, the canal, and etc. You don't have to worry, oh, this is a correlation or convolution, and do I need to rotate by 180? Of course, would be notified. The question will provide all the essential informations. Okay, so don't need to bother about this one. Okay, so in this slide, again, I mean, you will found that there are zero padding as well, because this is the original image. Originally, you have 1, 2, 3, 4, 5, 5, and 1, 2, 3, 4, 5, which is a 5 times 5. The resolution for this is 5 times 5, and this is your kernel, which is 3 times 3, 3 times 3. So whenever you want to apply, this is the original one. This is the original. And the rest of these are zero padding. Okay, so can understand why you need zero padding is because when you apply the 3 times 3 pixel, so you will be able to process all these block lah. Okay, you will be able to process all these blocks, provided your filter is 1, 2, 3, 4, 5, 6, 7, 7, 8, 9. Okay. I hope you all can understand this one. And then after processing this one, then move the entire filter to another to the next pixel. After complete this one, move again, complete this one, move again, complete this one, move again, and complete this one, either move to here or maybe downwards, depends on your software. As long as you complete all the pixel inside your original input image, you don't need to apply the origin here, because this initially all these are zero padding. It is not your real image, so the filter will not be performed at your zero padding. It is just to complement, to support the filtering. Okay. Any questions so far regarding the correlation, zero padding, or the padding theory? Any of you don't understand? I worry that it's a bit complicated for you all. Any questions so far? No. Okay. Sometimes I quite worry when you don't have any questions. Okay. All right, all right. Okay. If you have any question, please feel free to ask. And of course, usually if you don't have any question, only two possibility. One is you already know this very well. The another one is you don't understand at all. You don't even know how to raise the questions. Okay. So please look into this one, because this is something very basic in image processing. Yet it is important. Okay. Without this, this is sort of common knowledge in image processing. So if you don't know this, then it's very hard for you to to process with the further I mean higher knowledge lah. Okay, so these are considered as fundamental. So again, it is the same. It's apply the this is the original image. Okay. Oh, okay. So and the rest all these all these are zero padding. So it will start with this pixel and then continue with another one and keep on continue. Okay, so that is how you will get this one. And if correlations, you just need to rotate this one. So initially is this one, this is the initial one, and this is the rotated. Okay, so that is why you have 1 2 3 4 5 6 7 8 9, and then 1 2 3 4 5 6 7 8 9. Okay, so you will get different result lah, because 180-degree different mah. Okay, so the convolutions of a canal W or the mask, canal, mask, window, filter is the same thing again. Of a size m and n with an image for f, x, y can be expressed as follow. So this is the same lah, like the previous one. S is equal to T R. Okay, R is your input, T is the operations, S is your output image. So it depends on how you want to put this together. But this is just general equations. So this is the input image as highlighted here, the light blue color, and the orange color would be the filtering canal. So this is to mention you perform for each of the pixel lah. Okay, each of the pixel, and Pij is your output. So among the popular filter are mean, median, Gaussian, and Laplacian. Okay, I think mean median is quite common lah. Eventually, you're already very familiar with mean and median calculation, right? Mean is just taking the average, and Gauss median is to take the first of all sort in ascending order, and then you pick the middle one. That's all. Okay, if the middle one is I mean, if the entire the number you have is even number, you just add together some of the two median value and divide by two. That's all. Okay. So these are the very common uh, filter type lah. Okay, Gaussian and Laplacian is another filter type which is being used in edge detection and etc. Okay, so since filtering is a neighborhood operation, depending on the size of the filter, there is a problem when it comes to a boundary pixel. Now explain boundary padding. To overcome this, okay, so this is why if you are processing the inner part of the picture, I mean image, should be no issue lah, because you have all the pixel within the mask. Let's say this is a 3x3 mask is being covered by the input image. But what if you are processing the edge pixel like this one? You are processing the edge pixel. So 1, 2, 3, 4, and 7, all these you don't have any pixel for you to process. And image and the image processing is not possible to process empty pixel. So to overcome this, the input is padded to ensure all pixels in the input image can be processed. Padding is used to extend the boundary of an image to avoid undefined operation when parts of the canal lies outside the border of the image during filtering. Okay, so by nature, of course, we only, I mean, most of the time, I give you example in 3x3, right? So you have a 3x3 pixel. But what if this is a 5x5 pixel? And this is the origin. So when you apply this one on top of it, you would have 5x5. You may need two more lines, right? Something like that. Okay, you may need two more lines to cover this one, right? So the padding pixel would be another two line pixel extra. One line, two line, and one line, two line. Okay, so please aware of this one. Not a must. Just put in one line. It depends on your pixel. I mean, on the filter size as well. So if this is a 9x9, so you're supposed to have a larger padding lah. I mean, more padding lah. Okay. The main purpose of the padding is just to accommodate the empty pixel. Okay, no matter how big it is or how small is it, the minimum, the minimum would be one time. I mean, one line lah. Of course, one line lah. Okay, if this is just a point operation, which means only one box, so of course you don't need any padding lah. Okay, if this is a 5 times 5 or 9 times 9 or 7 times 7, so you need to add in the padding accordingly. Okay, if this is a 5 times 5, you don't add in only one line, is insufficient to perform the filtering process. Okay, I hope this is clear. So again, the padding is used to extend the boundary of an image to avoid undefined operation when the part of the kernel lie outside the border of the image during filtering. So among the most popular padding types includes zero padding, mirror, and replicate. So I would say zero padding would be by default lah. Okay, even in MATLAB, zero padding would be by default. But sometimes people like to use mirror or replicate because zero padding you will form sort of black frame because this is your input image. So you will form another black color frame across your border. So some people don't like that. Okay. Sometimes people will use mirror or symmetric, or maybe some people use replicate. Okay, all these three are quite common, are quite common in the image processing. So zero padding input image array value outside the bounds of the array are implicitly assumed to have zero value, which means you put in the intensity and the intensity is zero. That's all. Okay. So mirror symmetric input array a value outside the bounds of the array are computed by mirror reflecting the array across the array border, which means you sort of, if you have five, so you put five here, like okay, something like reflecting, the boundary is the mirror, and replicate in which the value outside the boundary are set equal to the nearest image border. Okay, for mirror and replicate is more or less, but of course would be a bit different. Mirror symmetric and replicate padding method attempt to extend the characteristic of the image past its border. For zero padding, it is usually just the simplest, give a zero value. But for this one and this one, it is trying to extend or stretch out the information in the border, stretching out the information in the border in order to accommodate the filter size. Okay, for zero padding, it is very clear, simple, and direct. So this is the original image. Okay, and the rest of it is zero padding. You just put zero. Okay, and mirror and symmetric padding, this is the input image. And for mirror and symmetric, you take this, the border pixel as the mirror, and then you mirror the rest of it. Okay, according to the uh how many pixel you want to accommodate lah. If let's say you only want to add in one pixel for I mean one line only without this one, so you only mirror 5, 6, 7, 6, 7. Okay, so if you want to mirror more than that, for example, you want to mirror another pixel, so you might want to add in 11191. Okay, is it clear? So the main difference is that you take this the boundary as your mirror. Okay, of course you don't take this one value, you take the value just after that. Okay, so you mirror this one from this one, you mirror this one from this one. Eh, this one I put it wrong, sorry, should be the last one. Hey, no one tell me. Okay, you put on this one for this one, and the rest would be 6, 5, 6, 7, 6. But of course, this one is very rare because it might cause issue. I mean, error in your original image because this value is replicate from here as well. Okay, replicate from left and right hand side. So sometimes you by this you might have syntax error from your MATLAB lah. Okay, but the theory is remain the same lah. Okay, you just take the border one. Let me re-explain. You just take your border value, don't take this one, and replicate mirroring this one, put it here, and this one, put it here. That's all. Okay, the same thing for the top one. This one as your mirror value, You replicate this one to this line and this line to this line if necessary. Okay, so let us continue. If you have this one, so as mirror, this replicate here and this replicate here. Okay, so clear. Any questions so far regarding zero and mirror or symmetric padding? Yes, no, no. Okay, no. Okay. Sometimes I'm quite excited for face-to-face teaching. I'm not sure you all sleep in the class or how. All right. Okay. So this is replicate. So replicate is a sorry. Yeah, this is replicate. Replicate is a bit difference from the mirror because you just directly replicate. Okay, which means you don't have any mirror lah. Okay. Um. So this is 3 and 5. So the yellow color is your original. Is your original. This is the original pixel. Okay, so by using replicate, you just replicate this one here and this one here. Okay, yeah, the philosophy is the same, but you don't have any mirror here. Do you understand? Okay, this is of course you can define it by your own. I don't want this. I want create my own padding. It's okay, up to you. Okay, just that sometimes we don't really um uh spend our time in these trivial things. Okay. But of course, if you want to design your own padding and the padding is proven to be much more better than all these common padding is okay. That is another a novelty as well. Okay. This novelty is quite good also because if people found that this is more really proven the applicability, people might want to use this by default later on. Okay. By doing that, you can reserve your copyright and etc. Okay, eventually we are say, oh, threshold is no good, additive thresholding is no good, because this is cannot obtain a very accurate result. But in fact, all people eventually in the non-destructive testing and evaluation industry, we are using thresholding. Okay, because why we want to use thresholding? Because thresholding is very very simple, it's very easy to implement, and sometimes the time taken in uh, processing the thresholding is very very fast, so it is still preferable in the real engineering work. Okay, so even although many people complain, oh, thresholding no good, the output is this and that, but yet it is still using in the current world. Okay, so yeah, if you have time you can also venture in this part lah. Okay, you might propose a better padding method. Okay, and that one is mostly more on fundamental lah. Okay, if you have a strong fundamental, perhaps you can do this. It's very good because this really contribute to the knowledge of the image processing lah. Okay, so again, the main difference of the mirror and symmetric and also the replicate is only mirror you have a mirror. Replicate you don't have any mirror. That's all. Okay. It is very direct. Anyone confused with padding or zero padding, symmetrics, replicate? Anyone? Feel free to raise questions if you don't understand, or maybe um you need me to re-explain a certain part. Yeah, feel free to ask. Anyone? No. Okay. Mm. Okay, so this is the effect after you perform zero padding, mirror and replicate. Of course, for mirror and replicate, you can't really identify the difference because you have to know the difference is like 1 or 2 pixel line difference. So it's very hard for you to observe by using your, I mean, human eye. But if you read you double click this one and you read the intensity value, then you will find that, oh, you will find this pattern lah, this pattern in your new image, output image with the replicate, mirror, and zero padding. Zero padding would be more significance lah. Okay, but if you want to, oh, I don't want to put zero padding, I want to put a white padding, is okay, up to you. Okay, it depends on you as well because there is no stringent rules that oh you cannot do this, you must select this. No, in image applications, the main purpose at the end of the day is to achieve your main objective. Depends on your applications. Okay, so that it is. Okay, let looks here. So you all know why you need padding and why padding is important. And yeah, this is important. Okay, mean filter. The output pixel value is computed based on the average value of the neighborhood pixel. So I already explained this one in the beginning of this. Yeah, maybe we can take five lah. Okay, we take five first and then we continue. Mm. Now it's 2:06. Take five, then we back by 2:10. Okay, we take five and then we back by 2:11. Okay, let's continue. So mean filter. Okay, mean filter. So I already explain. I mean, I already briefly explained the mean filter just now. Basically, it is just to get the mean value and then averaging out the value to get the mean, like you how you calculate the average lah. Okay, but this is applied in the image processing. That's all. So actually, it's good. I mean, in my opinions, the image processing is actually dealing with mathematics as well. So if you are good in mathematics, you can actually convey most of the mathematical theorems into uh, image processing algorithm. That is because um, the the image processing is actually dealing with all those sort of mathematics as well. Just that you are meant to display it later on with some of the meaningful purposes. That's all. Okay, so if by using the mean filter you can actually uh display it, I mean later on like convert it to become like a beauty camera, this and that. Medium filter you can use to filter out salt and pepper noise and etc. So all these kind median mean are quite common to all of us, and of course some other like the Gaussians, Laplacian, all are quite common, okay, in mathematic calculations. But we can actually adopt this and put it into image processing to achieve the purpose that we want. Okay, it's very again depends on your applications. So the most common one would be the mean, median, Gaussian, and Laplacians. Okay, means you the output pixel value is computed based on the average value of the neighborhood pixel. So you have to consider the uh neighboring pixel. You have to consider neighboring pixel. It depends. It is a 3 times 3 or 5 times 5 or 9 times 9 or 7 times 7. Okay. If you have a larger, if you have a larger filter, so basically you would expect to have a blurred image lah, okay? Because when you have a large filter, which means you need to consider more pixel, more and more neighboring pixel. So when you are considering more and more neighboring pixel, so basically the discrepancy from your current pixel and the new pixel might be a little bit different. The possibility of the discrepancy will be a little bit different. If let's say you have entire black color image, of course there will be no effect. But if let's say you have entire black image and you have made this entire white image and you have a black dot. So this black dot will actually smoothen out because uh, the white color would have intensity of 1, right? The black color will have intensity of 0, right? So if you have all the one divided by 0, maybe you divide by 9, so the value would be somewhere between 0 and 1. Okay, so you will replace this current pixel to become a gray color pixel. Let's say you have intensity from um, span from 0 to 1, which is being normalized. Okay, you might have a value maybe 0.5. So the black color pixel, which is a pepper noise, would be removed and replaced with gray color pixel. Of course, the noise still appear there, but the intensity, the intensity or the strength of the noise will be reduced. But if you are using median filter, so because you are going to arrange in ascending order, right? So 0, 1, 1, 1, 1, 1, 1, 1, 1, 1, let's say lah. Okay. Then you pick the center value. So basically you can successfully totally remove the salt noise. Sorry, this is a pepper noise because it's black in color. Okay. Um, I'm not sure if you all know what is salt and pepper noise. Salt and pepper noise. The color of salt is white color, right? The color for pepper is black color, right? So which means salt and pepper noise. It is means by your input image is corrupted by white color pixel and black color pixel. Okay, it is a fuzzy noise. Okay, nevertheless, this fuzzy noise is very extreme, either black color or either white color. So for white color noise, we know it as salt noise. For black color, we know it as pepper noise. So basically, if you we usually we call this as a combined name, salt and pepper noise. Okay, but yet still depends on the nature of the noise. So basically by using the medium filter, you can better remove the salt and pepper noise because you are sorting it out from ascending order and pick the center point. Okay, you are not arranging. But when you are meant to arranging the value of like the mean filter, so perhaps you will not be able to retain, you will not be able to remove completely the noise, the salt and pepper noise. Okay, so the filter perform the operations of second bullet point. The filter perform the operation of arranging low pass filter, smoothing or blurring. So large filter size, hence larger neighborhood, increase the blurriness of the filter image. So this is an example of 3x3 arrange filter. It shows in below. So this one is the input image. This is after filtering lah. So it is obvious that you can actually observe that after the mean filter, eventually using 3x3 pixel alone, you can see the image is actually being blurred out lah. Okay. Um, let me check what else. And some of the white intensity, like the fuzziness in the oceans, would be this is not ocean, this should be the grass, the paddy grass. Okay, the grass lah. Okay, the grass is being um, you can observe this as a salt and pepper noise, but the salt and pepper noise is being smoothed out, and the effect of smoothing out a pixel, you can actually same like a blurring out lah. Okay, so blur out everything, the edges of the building, the head, the edges here is all being blurred out. Okay, by using just the 3x3 pixel. So this is another example. This is after 3x3 mean filter, 5x5, 7x7, and 15x15. So by using higher, I mean the larger the filter size, you will find that the greater the blurriness of the output image. Okay, because you need to consider more and more pixel. 3x3 which means you need to consider 9 lah. So 5x5 is 25, 49, and etc. Okay, so the target pixel to be processed by the mask is pixel I22. So I22 uh you can see this as 1, 2, 3, 1, 2, 3 lah. Okay, I22, which means this one, the red color one. So basically by applying the mean filter, which means 22 plus 77, 48, divided by 9. Why divided by 9? Because you have a 3x3 kernel, so you will get 92. So the center pixel 77 would be replaced by 92. So the new input image would be 22, 77, 48, 150, 92, 158, 077, 219. Okay, always bear in mind, the only thing changed would be the center pixel. The rest of the pixel, the rest of the neighboring will not change because you only process the center pixel. And then this window will move to the next one. For example, move to this one. Okay, so if required, you need to perform padding 0, 0, 0. Let's say you are using 0 padding, 0, 0, 0. So the filter is now applied here. So the output of this pixel would be used to change this intensity. Okay, and the rest of the intensity remain unchanged. Okay, so this is how I mean, all the filter is being implemented in such a way lah. Okay, depends on what is the operation, mean, median, and whatsoever. Okay, any question regarding this one? Any question regarding I mean, I'm not sure how this one is being implemented. Can you explain again something like this? Any? No, okay. Okay, next, medium filter. So basically the philosophy of how the filtering is being applied is the same lah. Okay, just that different different working principle. No, should be the working principle is the same, just the operation is different. For example, arranging, median, Gaussian, Laplacian, the operation is different, but the working principle, how the window being moved, need to put in zero padding and etc. would be the same. Okay. So next we look into the median filter. So each output pixel is assigned the median value. So median value is actually very simple. You just need to assign it according to the ascending value and then pick the middle one. So let's take this as an example. Let me clear this first. So basically you need to arrange this in an ascending order. So which means 0, what next? 22, 77, 77, 77. Yeah, I missed up. 48. No, 77, 77, 77. 150, 158, 219. So we get the middle one, 1, 2, 3, 4, 1, 2, 3, 4. So the value would be 77. So by using median filter, before and after the median filtering, the value remain at 77. Okay, because based on this lah, that is how median being implemented. Okay, so median filter is better at removing salt and pepper noise. You have to, the median filter is better in removing salt and pepper noise, but it is not a must better in removing all kind of noise. Pepper and salt and pepper noise is only one kind of noise. Okay, there are much more different noises out there. Okay, so why it is the median filter is better in removing the noise. Let me give actually I already give you this example. For example, you have 1 1 1 1 1 1 0 1 1 1 or maybe 0 lah. You have pepper salt noise lah. Sorry, this is a pepper noise. So when you arrange in ascending order 0 0 and 1 1. Okay, something like this. So remove the 4 3 4. Okay. 3. So you will get 1 lah. Okay. Eventually, I give you another example lah. Realistic example 0 0 2 2 1 100 200 maybe 80 40 40 70. So after arranging 0 0 40 40 70 80 100 200 2 2 1 0. Okay, so 1 2 3 4 1 2 3 4, the current pixel would become replaced by 70 lah. Okay, so this is how you actually can remove the um salt and pepper noise effectively, because salt and pepper are two extreme noise. Okay, but why mean filter is less likely to be able to remove the noise? Is because let us use this example simpler. So you have 7 plus 0, right? Divided by 9. So 7 divided by 9 would be some float number, right? So this float number would be affecting this value, and this float number would be between 1 to 0 lah. So it would be somewhere around gray level. Okay, gray color lah at the end. Okay, so because this one the 0 value here tend to um pull or affect act as an outlier and affect the entire calculations of the uh, final output pixel. So that is why when you are using mean, the outlier will greatly affect the result. But median, the outlier did not, will not interrupt lah, because the outlier will be placed at both sides, right? Even uh, either left extreme or right extreme. So the center point will never be affected by the extreme value. But for mean, it will be considered in the calculations. So it will actually pull your point. If you have a lot of points here, and you have 1 point here. So if you want to calculate the median, median for this one basically have no function. Your value would be somewhere around here. But if you have this point and you have one outlier here, so when you calculate the average value, you would be somewhere around here. Okay, so that is the difference between mean and median. So this is the original image, 30% noise level, 70% and 90%. You can actually introduce the noise in the MATLAB. I think using IM noise, and you can even choose what type of noise, salt and pepper, Gaussians, this and that, many other different noise. Try to search in the Google search engine. Perhaps if, you can find more ways to introduce the noise. And you can introduce also the percentage of noise. How many percentage you want the input image being corrupted by a specific noise. Okay, so this is how flexible of for MATLAB lah. So image corrupted by salt and pepper noise. So this is so-called a salt and pepper. You can observe that the uh, noise would be black and white color. So white color would be salt noise, black color would be pepper noise. This is how we call actually. Okay, so the noise would be usually in rectangular shape because it's only corrupt one pixel. The pixel is always come in a rectangular shapes. Okay, so this is salt and pepper noise, and this is after filtering by medium filter. Okay, anyhow of filtering by medium filter, you would still found that the the image is being smoothed out. Okay, this is the after filtering using mean filter. So you will found that, oh, still got a lot but when you compare with the original image, the intensity is being reduced. I mean, the strength of the noise is being reduced. But for the median filter, you basically can remove all the salt and pepper noise. Okay, and the median filter, I mean, even for both median and mean and median filter, you will smoothen out the image because it is inevitable. You will still, for example, all these sharp edges, you will still select the median value, and by selecting this median value, perhaps you cannot preserve all the sharp edges, but I think it's possible for you all to, I mean, by looking at this, I think it's possible to play around with, you know, use the median value, and from the median value we can set condition, just like the thresholding. We set the condition if there are extreme value found, so we will not we will use the median value. If the extreme value is not found, so we will preserve the current value. I think this one can avoid. I think by using this way, we can actually the avoid the blurriness after applying the median. This is a good example. Okay, let us continue. Example one, determine the value of center pixel after median filtering with window mask 3 times 3. Okay, so let me check. Is there? Oh, okay. So try spend your time to work on this one. Yeah. This is very simple. This is the original image, and you perform median filter. Okay, try to work on it. Maybe 5 minutes. This is very simple. Should be no issue. If you know how to do this, should be no problems. Okay, the theory is the same. Try to do this. Okay, let us look into this. This is quite simple. Okay, uh, I wonder why teaching this simple mathematics. Okay, this is just a median filter. So as long as you understand the theory behind to figure out this is more or less the same. Okay, but most important thing is this is just a simple example, but in real life applications, it would be a little bit different. Okay, still using, I mean, still like a window sliding through all the pixel in your input image, but the way the calculation evolve would be much more complex. Okay, like a morphological operations that will be teach later on. It is very simple to to dilate or to erode the image, but later on we can combine dilation and erosion in different sequence. We form opening and closing, and by forming opening and closing, you can actually uh, change the structure elements to make it, one line, circular, this shape, different shape, and you perform different kind of morphological filtering for different purposes. Okay, so you are actually, mathematics is like plus minus, multiply and divide by, right? But later on, you will add in many more different method to organize it, and it become more and more complex. Okay, so target pixel is 1 2 3 1 2 3. Okay, or it is being mentioned elsewhere, like, okay, maybe they would have different scale, so 2 would be referring another point and not almost the origin. Okay, it depends on the point as well. Okay, so 2 would be referring to 150. So we sort out, arrange in ascending order. So after arrange in ascending order, you just cut off the point, the four and four behind. So the final will be 124 lah. So after that, the final pixel would be 124, 126, 127, 120, 115, 119, 123, 125, and 124. Okay, and the median filter would be moved to another location and so forth. Okay, so Gaussian filter based on Gaussian function. Gaussian is another function which is commonly used in mathematics, especially in filtering. So the standard deviation of the Gaussian function control the shapes of the filter. Standard deviation would be mm, standard deviation. Okay, this would be the symbol. This is a standard deviation, which is how um, how widespread is the entire data from your mean value. Okay, so if you have a very small standard deviation, which means your graph should be something like this or this one. Okay, which means all the point is surrounding the mean, thereby you have a very small standard deviation. If you have a very large standard deviation, which means you have a very widespread, widespread standard deviation, you have a widespread data lah. Okay, so yeah, that is standard deviation meant for. Sometimes it's very important in calculating, identifying sort of the statistic informations. So Gaussian filter can blur an image and to remove details or noise. So an example of Gaussian low pass filter mask, which is with a standard deviation of 0.85. So this is the input image. So this is the output image. So as you can observe, this is the pattern for Gaussian low pass filter. Perhaps different high pass, whatever pass, different pass, different filter, different filters types. You might have a different patterns. So for this one, the patterns for low pass filter will be 1 divided by 16, exactly as this one. Okay, this would be the pattern. Of course, you don't need to memorize. You don't need to memorize. Oh, this is low pass filter. I need to memorize this number. No need. So if this is appear in your examination, I believe this one will be given. Okay, you don't need to memorize it. Okay, so and as you can observe, the Gaussian filter is more or less like the median filter because the effect will be similar. It will remove the noise and also smoothen the image. And from this image, after apply the Gaussian filter, the original image is being smoothed out. Okay, and Laplacian filter. The filter based on the Laplacian operator, which is based on the second derivative. So the Laplacian filter image combined with the original image has the effect of sharpening the image. So whenever you are using the image sharpening, of course not all lah, but some, and the most common one would be using the Laplacian. I mean, when sometimes you go online, just type im improve the sharpness of the image, then it will appear sort of website for you to upload your image, and then it will improve the sharpen your image, maybe the age and etc. So basically, they are using the Laplacian filter mask. Okay, so Laplacian filter mask 1, mask 2, mask 3, and Laplacian filter mask 4. There are different types of patterns. I mean, different patterns lah. Okay, but they still have the same effect. Okay, so you have type 1, 2, 3, 4 different masks. Okay, they share the same how should I put it? They share the same characteristic, but different with intensity. Okay, for example, 0 to 255, all are intensity, but with different strength in showing a particular gray level. Okay, so which means 0 is black and 255 is white color. Okay, so original image after Laplacian filter image, you will get this one. And later on, the recover background features by adding the original and the Laplacian. So after you get this one, actually Laplacian filter is to get the age. of the input image. So after you get the edge of the input image, and then you add into the original input image, you will have a sharpened, um, image. Okay, so it's a very, it's just like, you are, last time, when we are kids, I'm not sure if you did so. We like to, in the drawing class, we like to highlight the edge of the object using black color crayon, right? Something like that one. Okay. So this Laplacian filter is, in order to filter out the edge and then add in the edge to the original image. So this is similar to what we did. I mean, like we highlighting the all the edges lah. So you will find that, oh, the edge of all the object is being sharpened, higher contrast, this and that lah. So you can observe the object, the building behind, and also the grass. You will find that this one is a bit blur, but this one is very obvious. And when you look at this after Laplacian's filter, you will find that there is a lot of white dots, and they are shapes, the shading of the building, the shading of the camera stand, this and that. So for this one, the stand, the fine texture of the camera might not be so detailed, but this one is much more detailed. Okay, but of course, if you have noise, for example, if you have a salt and pepper noise somewhere here, the Laplacian will highlight the noise and add into this original image. So you have to know the drawback. Okay, if let's say you have your image being corrupted by salt and pepper noise, and you try to apply a mean filter. So after mean filter, you would expect to have, uh you would expect cannot remove all the salt and pepper noise, right? Because mean filter never successful to remove the noise. So after that, you apply Laplacian filter, so you would expect you enhance the strength of salt and pepper noise later on, which means you waste your time lah, apply mean filter and followed by Laplacian filter. Okay, so this would be some of the thinking lah behind the questions. So please do not just memorize the answer. If you understand the philosophy of medium filter, mean filter, and Laplacian filter, or as well the Gaussian filter. So whenever this question is being merged from um, higher cognitive level questions, so you should be able to think accordingly. Okay. So geometrical transformations. So that is all for the local operation. Of course, there are much more different kind of filter, local operation, and etc. But for the current chapter, we only explain until here. If you need much more, I mean, if you need more information, of course, you can always search online and find the reference book and etc. Okay, there are too much uncountable, I would say, uncountable operations out there. Okay, so next we are going to learn the geometrical transformation. So these geometrical transformations would be a bit different. When we talk about transformations, you have to be aware what type of transformation it is. Because in image processing, we actually have two types of transformations. I believe not only two, maybe more than two. It's because transformation is a common word, right? We can actually transform from spatial domain to frequency domain and to some other different domain. Okay, so this is to transform the entire image to another level, another dimension. Okay, but geometrical transform, when we deal with geometrical, it is always regarding the shape, um, the scale, the size, the area. All these are referring to geometrics. Okay, so when we deal with geometric transformation, so it would be very clear. It is like maybe I've maybe in form 4 the transformation whereby you will need to draw your shape on the Cartesian plan, transform horizontal flip or vertical flip, or maybe scale up, scale down, um, transform from one location to another location. Those are
those are what we know as geometric transformation. Okay, so a geometrical operation change the image size, shape, and orientation of the input image. So this is just to um, scale up, scale down, just drag your image to whatever size you want. Like what we are doing all the while using Microsoft GPT, drag the image, drag the size, and etc. Okay, so it maps pixel information in an input image to another location in an output image. The operation include the following lah: scale, rotate, reflect, translate, and shear and skew. So this shows the operations, geometrical operation. Scale is to scale up or scale down. Rotate is just to rotate to whatever degree. Reflect is just to reflect. Translate is to move from one location to another direction. And shear or skew is um, like this one. I also don't know how to describe. Put it to a specific way and change in the original shapes. Okay, geometrical. This is repeated. Okay, scale. Change image size by the proportions of x, s, x, and sy. Um, Scale is actually scale up or scale down. Like you scale up or scale down the entire image. But for this one, you only scale a specific object. Okay, you can actually do so in your MATLAB. You scale up or scale down a specific, but of course, by doing so, you need to do your own algorithms. Okay, if you want to scale up or scale down the entire image, you just use IM resize will do. Okay, I think it's IM resize or IM size. Okay, so basically, it's just to map that. This is just for information. Okay, how the scale up and scales. I mean, how the scaling is being performed. Rotate, rotate image by a certain degrees in a clockwise or a counterclockwise direction around its center point. Um, for our current, learning in the multimedia tools and applications, multimedia technology and applications, perhaps this is not so crucial, but when you come to um, like what I keep on mentioning, non-destructive testing and evaluations, this rotate is very important because you want to rotate the image in a correct manner so that you can perform all other defects inspection accordingly and with a faster rate. Okay, no matter in semiconductor or maybe pharmaceutical or any beverage food and beverage line F&B, you still need this knowledge. I mean, you still need to use rotate um, frequently. And for your informations, to rotate an image in the image processing is quite time consuming. Okay, and the scale, how many degree you rotate is quite time consuming. So that is based on my experience. When you want to rotate the image, make sure you need to check the interpolations. What is the degree you want to use to compensate the rotation? Because you don't want to have a length. I mean, you don't want to consume too much time in the rotations because rotation is very time consuming. Of course, the time consuming is not up to 1 second, but maybe hundreds of millisecond. Because millisecond is the scale we are using to measure the speed of the algorithm. Okay, so rotation is simply just rotate left and right. And in MATLAB by default, if you are exceeding the original default frame, it will be cut off. Okay, so it will be cut off. But of course, this information is not being removed, but it's not being displayed. Okay, because when later on this image, you want to rotate back to this one, all these corners still can be displayed later on. Okay, which means the information of this missing corner is not being uh, disposed. Okay, it is just not being displayed in your MATLAB. Okay, so and also after rotate, the MATLAB will not show you just this lah. The MATLAB will not show you just this one. you know, only the center. No, it will pad the rest, the corner with black color. This is by default lah. Okay, this is how MATLAB compensate the original image. So reflect is just to reflect horizontally or vertically, 180 degree or usually it's 180 degree lah. Okay, translate is to transform, move the object from one location to another location without scale up or scale down the input image. So this is known as translations. You just move to a new location. So the first order of polynomial is used to change the x and y image coordinate, translate a point to a new location by adding translation amount. This is what we learn in Form 4 lah. Okay, translation is just to add in the how many block you want, how many pixel or how many block you want to move to left or right or and up or and down. Okay. So this is to transfer from here to here, which means this location to this location. So basically, the block will not move we don't move 45-degree upward, but it will move how many blocks to the left, to the right, and how many blocks to the up position or the top position in order to reach this position. Okay. dy and dx, yes, this is differentiations, and dy and dx is actually referring to um, the different in block. Okay, the small difference. So this is how we actually use that. Okay, differentiation is very important, and also integration is very important, especially in the control system. Okay, so basically all those small differences, we are actually referring using dy dx. Okay, just that dx is referring small difference in x and z, dy is referring small difference in y and z. Okay, so please do not say that all those mathematics learned in Form 5 is not important anymore. Actually, it's being used, just that you don't know. Okay. Translation, shift an image in coordinate space by adding a specific value to x and y coordinate. So translation is more or less, translation is just to translate to another location. Again, the image which is missing at this position is not being disposed, the information. It is not being displayed only. Okay, because after that you want to translate back to this one, it will still display. Okay, and again, this is depends on the software. Some software may dispose these image informations. So later on when you move back to this one, it will become smaller and will compensate the rest with the black color because the information is being disposed. Okay, and this black color, because to preserve the original size of the image, because you are not using crop function. If you are using crop function, so the entire image will be cropped, become smaller. Then no black region here, no black zero padding over here, because you are using cropping features. But if you are not using cropping crop features, you are just translate, which means you are moving something inside your frame steadily. If you move this side, so this will be pad with zero. If you move to upward, so this will be pad with zero. But if you are meant to use crop features, then which means you will crop this and display only the result after your cropping. Okay. So shear and skew is like what demonstrate previously in the previous slide. So it is just to hold it or hold the input image into a specific directions, like parallelograms, this direction. So the rest will be pad out with the zero padding by default. Okay, the same thing. Any questions so far? I think the geometric transformation would be quite simple because it is we already know all are already known, rotate, translate, shear, the the reflections, all these are quite common to us. Okay, any questions so far? That's all. I think that's all for today. If you don't have any questions, um, no questions. Later on 4:30. Sorry, 4:30. 4:30. We have our tutorial class. So remember, both all the students are join. we have our tutorial class being revised to even week, which means week 2, 4, 6, 8, 10, 12, and 14. Okay. 4:30 to 5:30. I'm not really sure we did we finish tutorial one. If we not yet finished, then we will complete tutorial one first and followed by tutorial two. Okay. Any questions so far? No. If no, then that's all for today. And again, from time to time, we may revise the mode of teaching. Depends on the COVID pandemic situations lah. Okay. Hopefully everything goes well, and we will back to campus very soon. Okay. If no questions from the floor, so that's all for today, and thank you. Bye bye.